What was I thinking that we were done with VTP? There was one more feature I wanted to show you, and it is a short and sweet one, and actually is a bonus for you putting up with me on that. I'm going to show you another difference between versions 2 and 3 of VTP that I think you ought to know about. That one's simple too. So some light stuff here. Let's dive right in with VTP pruning. Now we know that our trunk ports are members of all VLANs by default. We got that down. And that leads to an issue though with unnecessary traffic going from one switch to another. Now, even if the downstream switch needs to know about the existence of a VLAN, maybe it doesn't need all the traffic that's destined for that VLAN. And we're going to do a two-switch walkthrough. I'll show you exactly what I'm talking about. Because a trunk port, it's going to forward broadcast and multicast for every single VLAN that it knows about, regardless of whether the switch at the other end of the trunk has ports in those VLANs. And that means the sending switch is likely sending unnecessary traffic, and the recipient is definitely receiving some totally unnecessary traffic. Let me show you exactly what I mean right here with this diagram. And a quick walkthrough here. Switch 1 has hosts in VLANs 2 through 19. Switch 2 has hosts in VLANs 2 through 10. Well, if switch 2 doesn't have any downstream switches, which in this case it does not, there's absolutely no reason for broadcasts and multicasts that are for VLANs 11 through 19 to go across that trunk, because you actually have 3 points of unnecessary work. Switch 1 is sending broadcasts and multicasts that don't need to go, and they got to be prepared, they got to be packaged, they got to be sent. That's a little bit of a hit to our switch. We're sucking up bandwidth that we don't need to suck up with those broadcasts and multicasts. And then on top of that, switch 2 still has to examine these broadcasts and multicasts and say, okay, I don't need these anyway, so I'm just dropping them. So that's a lot of work for traffic that's not really going anywhere anyway. What VTP pruning allows the switch to do, in essence, is to announce to a downstream switch, hey, I've got ports in VLANs 2 through 10, and, that's it. I really don't need any other traffic. So what happens is, the switch realizes that, the switch on the other end of the trunk, and in this case, switch 1 is sending a broadcast for VLAN 14. Well, the thing is, previously, before we turned pruning on, that broadcast would be sent, it would go across, switch 2 would say, I don't need that, and drop it. But in this case, with pruning on, that doesn't happen. Switch 1 never sends it. So that's a huge advantage all the way around. And best of all, frankly, it's really easy to configure. You'll love this. And we've got a conf t VTP pruning. No options. Congratulations. Now, I already had it on this particular switch. Let's go over to switch 3. And we'll do a VTP pruning. And pruning switched on. It is off by default. And you can verify with show VTP status. And we've been running this command, running this command an awful lot. Let's go ahead and go back up here and you can see where it is. VTP pruning mode is now enabled. Again, it is off by default. You'll see disabled there by default. And really, that's almost all there is to do with pruning. That's about it. Now, on occasion, you may want to prevent certain VLANs from being pruned. Doesn't happen a lot, but you can do that. And let me show you the command for that. It's let's do a show CDP neighbor. Make sure I'm putting it on the right local interface. So it would be 012, the local interface. And it's switch port trunk pruning VLAN. And then you've got your options, and these options should look a little familiar, maybe with another command where we were actually allowing and permitting or denying traffic. Well, what you can do with switch port trunk pruning VLAN is actually control which VLANs can be pruned and which ones can't. Now, by the way, when you turn pruning on, the 5 default VLANs that we know and love so well by this point, I know you know those numbers, those cannot be pruned. Even if you try to enter 1 here, it's going to say bad VLAN pruning list. And you just go, well, wait a minute, why is that a bad VLAN pruning list? Well, the thing is, if we're trying to add 1, and let me do that. Let me do an add 1 there instead. So we're pruning VLAN, add 1. We're still getting bad VLAN pruning list. So it was not my syntax. The command is being rejected, and it's being rejected because VLAN 1 is a default VLAN. It cannot be pruned. And we know the others, but let's have a quick look here. 1 and 1002 through 1005, those cannot be pruned. But if for some reason you went in here and you just said, okay, I don't want VLAN 100 to be pruned, you would simply put switch port trunk pruning VLAN except 100. So the options are really unlimited there with add, accept, none, and remove. But again, please keep in mind with pruning, it's off by default. And on top of that, you cannot prune the default VLANs. Now, I wanted to show you one more thing here. It's interesting about VTP version 3, and this is beyond the scope of the CCNA, but I want you to see it because you'll definitely run into it when you start running version 3. So we've got it running between versions 1 and 3 right now, and let's say that I wanted just to create some VLANs here. Okay, and switches 1 and 3 are the only ones in the mix. So I'm in a lab and I'm doing this, and I want to create VLAN 200, and I do it the same way I've been doing it for a long time. But I get a message now that I've never seen before. VTP VLAN configuration not allowed when device is not the primary server for VLAN database. Well, that sounds kind of like something to do with the modes, right? Like server and client, that kind of thing. So you run show VTP status, and you see right there VTP operating mode is in server, and that's all fine. So what exactly is going on here? Well, maybe it's just something, I must have missed something there, Chris's videos. So I'll go over to the other switch and try to create it there. And I get the exact same message. Okay, with version 3, you've got to create a primary server, and that's the only device that you can actually create VLANs on. And yes, I did learn that when VTP version 3 came out, and I tried to create VLANs the way I always had. And you go into config here, and you see domain, and there's something about a file and interface, mode, password, pruning, and version. Most of these we've seen so far. So what about this primary server jazz? Well, I don't see anything there about a primary server. Let's see if we have an option here. And well, we really don't. There's nothing here about a primary. That we're getting into some VTP instances here, and we don't want to get into that. So how do I make this my VTP primary server? What you actually have to do is go back to enable mode. That's where they stuck it, so that's where we have to use it. So I'm going to use primary here, and I could just go ahead and hit enter. And you'll notice this system is becoming primary server for feature VLAN. What is the password? And it gave me about 2.5 seconds there to put it in. So you even have to know what the password is to get this done. And that always takes a second or two, or perhaps more than a second or two. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, go. Hey, so what it's doing is looking for conflicting devices. And what it's doing, of course, is actually saying, okay, is there another VTP3 device out there that's already been named the primary server? Because as you gather from the name, you can't really have multiple primary servers. I want you to have one. And then finally, you do get this confirm, and there's the MAC address of this device has become the primary server for the VLAN VTP feature. So finally, I would now be able to create VLANs. But I remember running into that when I started with VTP version 3, and I just had not seen the primary server concept. So again, beyond the scope of your CCNA exam, way beyond it actually, but I thought it was good stuff for you to see, especially for lab work. So now, one more version, that's it. One more version difference, and I do want to show you this, because when you're working on different switches or different routers, of course, we have to get used to, slight differences in the iOS, that kind of thing. I like to expose you to some of that here. There's one more thing I wanted to show you about those VTP modes. First, I need to learn how to spell conf, but we've got VTP mode, and notice here we have client, off, server, and transparent. We have off mode, which of course is basically just, turning it off. Well, if we go over to switch 2, and just as a quick reminder, this is a VTP2 capable switch that's running version 1 right now. It's off by itself. It's not even in the domain. Notice that it does not, pardon me, notice that it does not have an off mode. That's another version 3 deal. So to have a hidden password, to have a secret password, to have off mode, you've got to have VTP version 3 up and running. So I think we've talked enough about VTP version 3, but you will be running into it in your future studies with some more advanced switch features that VTP helps to make possible. So now coming up next, unless I'm mistaken, and there's always that possibility, spanning tree protocol coming up next. See you there.